Welcome to this video on defining business rules. In this video, we'll talk about defining business rules in BIZUIT. Business rules determine how a process behaves in different scenarios. Setting them correctly is essential to ensure that processes run efficiently and remain aligned with your organization's goals. Control flow in business rules. In BIZUIT, flow control activities allow us to define business rules. These activities ensure that specific actions are only performed when certain conditions are met. For instance, in an order approval process, we could establish that only orders above a certain amount require approval from a manager. This flexibility allows us to model complex processes and adapt them precisely to business needs. Let's now look at the condition editor, a key tool in BIZUIT used in most flow control activities. It allows us to define the conditions under which activities or groups of activities will be executed. The editor lets you build conditions based on process parameters and variables. You can compare constants, process values, outcomes of previous activities, or fixed values. For example, in a vacation request process, we can automatically approve requests that are shorter than 3 working days. The editor also supports logical operators to combine rules and build more advanced conditions. Now let's move on to a real-world example. We'll define a business rule for our reimbursement management process using the condition editor. Rule 1. If the human resources system indicates that the employee is not eligible, an email should be sent to inform the applicant. If the employee is eligible, the request should move to an initial evaluation by someone from the administration area. This process has already been modeled, now we just need to configure the conditions. You'll notice that our branching activity has a red path on the left. This means the condition hasn't been set yet. A branching activity can have multiple paths. The last path on the right acts as the else, gets executed only when none of the previous conditions are met. Evaluation is done from left to right. If the first condition is met, it follows that path and ignores the rest. If not, it checks the next, and so on. To configure a condition, we use the condition editor. In our case, we want to check whether the variable v fulfills policy is equal to 1. This variable holds a value of 0 if the employee does not meet the policy, and 1 if they do. We add the condition. And that completes Rule 1. Rule 2. If the evaluation is approved and the refund amount is greater than $100,000, the request must be evaluated by the administrative manager. Remember, we had a variable called v-data-initial-evaluation, which is an XML document type structure. It contains the evaluation result. So, to define this rule, we can simply say when the result in the b_data-initial-evaluation variable is approved. That condition is going to be fulfilled. This means we need to check whether the result subelement is equal to 1. Once this condition is met, we need to check if the amount of expenditure is greater than $100,000. If so, the request must be authorized by an administrative manager. To simplify our process, We can configure a business rule that evaluates whether the parameter amount of expenditure exceeds 100,000. If that's true, the condition is fulfilled. Note that the value we compare against can be a fixed value, like in this example, or another variable or result from a previously executed activity or process parameter. Now, take a look at Rule 3. It states that if the evaluation is not completed within the required time, the request must be evaluated by a different administrative role. In this case, we have 3 branches: approved, rejected, and expired. If the request is marked as expired, regardless of the expenditure amount, it must be reviewed by the administrative manager. Rather than duplicating the interface and logic across 2 separate branches, we can unify them into one. So we'll create a condition that checks whether either the amount is greater than 100,000, the initial evaluation wasn't completed on time. To achieve this, we'll modify the condition using a logical OR operator and include the v_overdue variable, verifying if its value is equal to 1. With this logic, the authorization by the administrative manager activity will be triggered if either the expenditure amount exceeds 100,000 or the evaluation wasn't completed on time. In that case, v_overdue will have a value of 1. This allows us to eliminate a redundant branch and activity, making our process more efficient. Finally, we need to refine our conditions. For example, a request might be overdue and not approved, meaning it never passed the initial evaluation. To reflect that, we can adjust the naming of our branches. For instance, one branch can handle approved or overdue. Using an OR operator that checks whether v_overdue equals 1. This way, if the request is either approved or overdue, it follows the correct branch. Similarly, if the amount is over 100,000 or overdue, it will require authorization from the administrative manager. As you can see, this adjustment helps streamline and simplify our process model. Best practices for defining business rules. Now, let's go over some practical tips for defining business rules effectively. First, ensure that the rules are clear and easily understood by everyone involved. Group similar activities under the same rule to simplify the process flow, just like we did earlier. Always test your rules in a controlled environment before deploying them to production to avoid unexpected issues. And finally, document all important business rules so that your team can easily understand, maintain, and update them in the future. And that's it for this module. We now understand how to define and apply business rules in BIZUIT to effectively control the flow of our processes. I encourage you to put what you've learned into practice, and don't hesitate to experiment with the condition editor to create your own rules. See you in the next module, and thank you for watching.